So let's come now to the laboratory activity 9. So it's all about Z transforms and signal processing. So we have here the three objectives: to implement Z transform and inverse Z transforms using Python, analyze signals such as impulse, step, and exponential sequences, and to visualize Z transforms and their behavior in complex plane. So start this, we have here the code. Okay, so this is the code for the laboratory 9. So we have here for to import the NumPy, the Matplotlib, and of course the SymPy SSP. So first is that I've defined the symbolic variables, which is the Z and the N. So according here, sp.symbols and integer is equal to true and positive is equal to true. And now these are the Z transform formulas that's been printed, and here is the symbolic Z transform. So this is the formula Z over Z minus 1. So next is that we have for the manual inverse Z transform. Okay, it has been printed here. And for the numerical verifications, so it is just to verify if the things above is true. Okay, so to verify it, we have here assigned the values for n. So np.arrange, this is an array of 0, 10, which means that the arrangement is from the range of 0 to 9, and the values ones like n values 2, this will be printed, and delta n negative values. Okay, so it has also been printed these values, and here is that it's been created the to create a complex Z values for plotting. So yes, for the theta NP line space 0, 2 NP that pi. Okay, and R is equal to NP line space 0.12, 400 for the Z plot. Okay, and so what does this mean here? So this is to create a visualization of Z domain. So this is to create complex values of Z using polar coordinates. So the radius R here and P dot line space 0.1, 2, 400. So, and we have here also the points for the Z plot. Okay, so next is that to compute the Z transform numerically using the formula a while ago. So it has been transformed or computed numerically by the Z plot over Z plot minus 1. So it is very similar to the above. This is just to evaluate the Z transforms formulas numerically. And for the plotting, we have here the subplots and the axis. Here for the theta, this is first for the magnitude of the Z transform. The next output will be for the phase of Z transform. So it has labels, title, the plot, the grid, and the legend, of course. And next is for the magnitude of Z transform of delta, of course, and for the phase transform of delta. So as you can see here, we have for the UN and we also have for the delta. So the final layout here. So let's run the code. So here's the output of the laboratory. For the magnitude, the phase, Z transform magnitude, and for the phase of the delta. And it has legend, and it has the correct the right out. So yeah, that's all for this video. Thank you.